Hi, welcome back. So on previous video, I have shown you guys how I train my machine learning model so that it able to detect my face, recognize my face, then from there instruct DJI Tello to follow me everywhere. That's working fine, I'm happy with it, but now I want to extend the functionality. So I'm thinking to add some other modes, for example, emergency landing or emergency power down mode. So whenever I see there's a condition where it's not safe for Tello to fly, so I'm just send a communication or signal to Tello to shut it down. Yes, even though I have some other condition that will instruct Tello to power down, for example, if it's over temperature, battery low power, and also if not detect any object within 6 seconds. But there's a condition in the software and also on the hardware, but not on the environment. I'm thinking, what if the condition out there, the environment that Tello fly is not safe, so I want to shut it down even though the internal state of Tello is working very fine. So I need communication medium to talk to Tello. So at first I'm thinking to use voice recognition. Of course, need to learn my voice because I'm not a native English speaker. Not only that, I also need to put some microphone on the Tello, right? So there's some modification on the hardware and some other stuff that I'm not look forward into to do it at the moment. So I'm thinking, what is the most easiest way for me to do it? So I got an idea. If let's say if we can utilize sign language, for example A, L, and or Y, V, so I can send a message to Tello based on the sign. Let's say I put my hand like this, then Tello will enter the power down mode and then shut it down, everything. For sure, I'm positively thinking this, but I'm not sure how hard will it be to train your own dataset and preparing your dataset, even though yes, I know the flow of it, but previously I used my existing photo album from iPhone. So it's been a long time that I take picture, selfie, etc. Now I need a dataset to recognize this symbol, and also not only this picture, but it need to be some way that optimized for Tello camera as well. Enough talking, let's get down to it. So we have a new classes to be trained. First one, we need to train a letter A, then letter L, V, and Y. There's no particular reason why I choose this symbol, but I see it most easiest to be trained. For letter A, the functionality is to enter auto tracking mode. Tello able to move X, Y, and Z axis. Letter L to enter auto monitoring mode, which means it not going forward or backward from us. For the letter V, I reserve it for selfie mode, and letter Y for recording mode, and both hand 10 fingers to enter the power down mode. So first, open Kaggle website, find the sign language dataset with the image, and the size is large. This one got plenty of image that have different background, different people, and has a lot of image like a 2000 and more. This one as well. All of these can be used to train our machine learning, but depend on our usage. At first, I thought using Kaggle dataset is absolute bonus for me, so I unnecessarily to put effort to collect the dataset. After training finish, I using the model, try to predict using a webcam. It able to detect, but at some level it not able to detect if the object is far away. So that could be a problem because if camera stream from Tello, it will be far away from us. Usually like a 2 meters or 1 meters and half at minimum. So I refer back to Alexei AB repository, mentioned that there's some way to train a model to be accurate. For example, it can be better if we use Tello stream image, actual footage, and then we slice it down into some images and train using that particular image. So the training will be customized for Tello stream. Even though the camera is similar, for example, the webcam and also the Tello, but the perspective is different, and that perspective that we need to get from Tello. So I create a Python script to slice video frame from Tello into images, and these images that generated from video feed will be used in our training. So the name is autosnapimage.py. You can find in my Bitbucket repository, and the link I put in the description below. Okay, just take the input from the command line interface. I put some description, how it works, what it does, and then pretty much everything inside. So we can define the starting image index. Let's say the first image we want to, the number will be 22.jpg. So the image index start, you can put as 22, and interval snap time is mean when the next time the video frame should be sliced. If we put like a 0.1 second, then each 0.1 second it will create or slice the video and produce an image from there. And then if we want to convert the image to grayscale, for example, in my training, I convert the image to grayscale to reduce the bias on the background color, since at the moment I just training my image and my model inside my house, and the wall of my house is mostly white, so I'm afraid it will become a bias if I train the model behind a white wall. So it only detect object that has a white background for it. So I put a grayscale so that the image would be similar, even though there's still got some differences between, let's say, in red and white color. In grayscale there's some intonation difference. And then save the image using OpenCV and track out and track the last captured time. This is optional, but if you want to show the image that you have snapped, you can use the IM_show. Okay, done. So let's test this script using to capture using webcam. Put the argument, start index from 100, and the interval time is 1 second. So when I run, it will capture this video frame and convert to image. Yep, it's working. And then I'm using the image that I recorded using Tello previously, for example, to show you guys how I did it. So this is a free video feed from Tello, and then I generate the image for every 1 second. As always, I open the label image tools to annotate the image and label it as Buzzley, again me, and the letter me, the letter L. Yeah. However, I'm making mistake using Pascal VOC dataset, but luckily there's some guy create a YOLO to Pascal annotation conversion. So just download the repository. As always, I put the description below for the link, and then we can convert from the Pascal VOC label into YOLO Darknet label from XML format to .txt format. After completed training, I evaluate the model using Darknet detector map command. So I load all the configuration and the train weight that I already have, and I'm satisfied with the accuracy. So you have seen all the progress that I've made in a week. So yes, we can teach sign language for machine learning model using YOLO Darknet. I say this absolute win for me. Within this week, I faced a lot of challenges to preparing the dataset, to annotate the image, and it really tedious for me to annotate each label, even though it's just only 4,000 and it's considered small in machine learning world. I satisfied with the result for now, even though for the outdoor, for the improvement, we need to do some image processing before we send the image to process by YOLO Darknet. So see you later. Thanks for watching.